Prime polynomials are polynomials that cannot be factored. With a trinomial, the only way that we can determine that the polynomial is prime is by trying to factor it and trying all possibilities and determining that nothing works. So for example, on this first polynomial, I'm going to fill in a diagram where in the numerator, or rather in the top of the diagram, I put 3 times -8, which is -24. And in the bottom, I'm going to put the middle coefficient, which is -2. So in this diagram, I have -24 as my product, meaning that I have a positive and a negative number on the sides. Whereas looking at this other polynomial, I would have +3 times +8, which is +24 in the top, and -2, the middle coefficient, in the bottom. So on this second diagram, I would need numbers of the same sign to multiply together to get +24, and those have to both be negative in order to add up to a negative sum. Pause this video for a moment and try filling in both of these diagrams so that you can figure out which of them works and which of them doesn't. It looks like I get +4 and -6 working for my top diagram because the numbers of opposite sign are a little bit easier to find to add up to a small number like -2, whereas on the bottom diagram I could try every possible factorization of 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. None of these work if both numbers have to be negative. So it's only by considering every possible factor pair and having none of them work that I can determine that a trinomial is prime. If the factorization is going to not work somewhere along the way, it's going to be at this stage where we're filling in the diagram. If the diagram works, the factoring by grouping should always work. So if ever your factoring by grouping doesn't work, then you should look back at your diagram and make sure that you filled it in correctly. In this case, we would have 3x squared plus 4x minus 6x minus 8, and again, group by last two and first two, to end up with the factorization x minus 2 times 3x plus 4.